afternoon, good evening. How are you guys doing? Good to see you. Good to see everybody in here. Welcome to the Studio Q show live. My name is Quinn Jacobson, and it's good to have you guys aboard, whoever's here. We'll have people start jumping in on YouTube here in a minute. Got a good show, I think, today. Some interesting stuff we can look at and discover some. You know, it's nice to go over, look at this old literature, go over the things these old boys did, and keep that in mind, right? We work in it this much, they worked in it that much, and it's experience is the teacher here. I know there's a lot of good wet plate people out there, but there's also a lot of really bad advice. I get it every week. I get emails every week saying, is this true? Is that true? And it's like, wow, this is, it's interesting regardless. So welcome. Hello, Christian Johansson. Good to see you in here. We'll just jump right in and get this show going here because we do have quite a bit to cover, actually. You know, my little keep myself in tune stuff here. Good to see Jeffrey and Jan in the live room. Good. Thank you for joining us. I mean, I'd do this alone, but it's always nice to have somebody out there that's willing to jump in here. So, yes, today is September 18th, Saturday, 2021. Time it waits for no man or woman. We are just buzzing right along. So we're going to talk about iodides and silver bath today. And I know it's kind of a general topic, but it's really important to see how Hardwich addresses these, and I got a couple of other little tidbits to share as well too. Jeffrey sent something in that's really important. We'll cover that, and just a couple of odds and ends in the technical realm. Hello, Mr. Tim Fry. Good to see you, brother. And Chad, good to see you. We'll stream right along here. News and social media, technical Q&A, recommended reading, recommending watching or listening. Sometimes we'll throw something up there that has a little bit of listening stuff rather than watching stuff, or both. So this is an event going on starting in just a few days in Barcelona. I was invited to the very first one, and we had a really good time. It was amazing. Rivalite, Pep, and Joanne at the time did it. I think Pep's still running it, but there's a lot of good workshops. This is the first time what Collodion was introduced there. I think it was their very first event. I think it was in 2012, if I'm not mistaken. If you're in the area, if you're European, you can make it. This is an event worth going to. It is a big, huge analog festival. It's kind of like Bièvre in Paris, but a little more workshop oriented. They have a lot of nice artwork and things so you can see. So support them if you can. It is in Vilassar de Dalt and Barcelona, both places. Really beautiful. De Dalt and De Mar, the mountain and the sea, little villages. If you're in the Tucson area this week, Joel Peter Whitkin's got Journeys of the Soul. Check that one out. It's in the Etherton Gallery. I've never been to the Etherton Gallery. I've been to Tucson, but Whitkin's always showing something. He lives in New Mexico and taught at the university there, University of New Mexico, I believe. And so he's all over, though. He had shows in Paris. I mean, he's everywhere. So there's a couple of little pieces of news. This is something I ran across this week as well, too, this Midwestern exposure. This is by Kim Bell. I think I put the YouTube link up there. That's it there. You can go to lamppensquarterly.org and find it. But this is really interesting about the women in photography in the middle of the 19th century. Very underrated, very overlooked, you know, kind of like the minorities. It's always these white men dominating this stuff as I speak, ironically enough. But the idea here is to look at the women, and this is focused in the Midwest of the United States, and what they did. It's a great article. Go check it out. There's a couple of photographs up there you can look at as well too. Really interesting, super creative. I mean, the greatest influences for me have been like, you know, Deanne Arbus, Mary Ellen Mark, Nan Golden, Julia Margaret Cameron, if you want to throw way back. There's a lot of female influence here that we tend to overlook as the dominant gender. So check that out. It's a good one. Let's jump right in here. This is a manual of photographic chemistry by Frederick Hardwich, 1855. You should definitely download this. I'm going to quote out of a couple of his manuals, but this is a really good one. It's Manual of Photographic Chemistry, Practice of the Collodion Process. And let's look at what he says about iodides. This gets really interesting for me. We're going to look at iodides, and then we're going to look at silver bath. This gets really interesting for me of how, if you understand basic organic chemistry, the acids and basics, right? Alkalinity and acids, the whole baking soda and vinegar thing. This is really relevant to us in this process of how this process works, and trying to understand how these salts and collodion work in relationship to that, and the silver bath is super, super important. So let's check this out. This is section 2, iodized collodion. Now remember, this is iodized collodion. This is not bromo-iodized collodion, so he's going to make negatives here. In a former chapter, while speaking of development of a latent image by means of a reducing agent, we talked about Gallic, pyrogallic, and ferrous sulfate last week, or protosalts of, the protosalts of iron. We call it ferrous sulfate now. By means of a reducing agent, it was shown that the silver iodide was better adapted to the purpose than chloride. And if I'm not mistaken, was it you, Chad, that asked about chloride? Well, here's a great little example, and I mentioned this, but it was better adapted to the purpose than the chloride, not only being a more sensitive preparation, but also withstanding the action of the developer better in those parts not exposed to light. So that chloride's slow, great for prints and things, but we're talking about making negatives here. Although absolutely, you saw Eastman Kodak's recipe with that in. So it's not, nothing's ever absolute in this. You can add anything to these compounds you want. Whether you get the results you want or not is a different story. Yes, Chad said it was last week. Exactly. So there it is. Not only being more sensitive preparation. So he's saying that the reducing agent, the iodide, silver iodides, the iodide being more sensitive than the chloride, which is true. And you ask about that. So there it is. There, right from Hardwich there. Withstanding the action of developer better in those parts not exposed to light. Consequently, the colloidal iodide of silver iodide, will at present alone engage our attention. The present section treats of all that relates to the collodion, iodized collodion, and that one which follows the silver nitrate solution. So that's what we're going to do. We're going to talk about that, and we're going to jump into the silver bath. In order to produce the silver iodide, the plan always adopted is to select an iodide of some kind which is suitable in a mixture of alcohol and ether. Those are the really key components, right? Like what is soluble, what works best, what is happening with the solvents, the alcohol and ether, and to add a portion of this to plain collodion. Afterwards, a plate of glass is coated with a layer of iodized collodion, and whilst it is setting in a state neither wet nor dry, it's immersed in a solution of silver nitrate and allowed to remain until decomposition is complete. We know by this time what happens there. We pour the salted collodion on the plate, we immerse it in the silver bath, and this double decomposition happens. And that's what he's talking about there. He just calls it decomposition. The points of interest are these: the nature of the iodide best adapted to the purpose, very important, and the chemical changes which the iodized collodion undergoes by keeping. So what variant are you going to use? Are you going to make positives or negatives? And how long do you need it to sit on your shelf before it decomposes so bad you can't use it, right? Those are the two considerations. So in part A here, he talks about nature of iodide best fitted for iodizing collodion. The iodides of potassium, ammonium, and cadmium have all been employed for the purposes of iodizing collodion, and each one has its respective advocate. So even back in 1855, we're talking, Joe like this, Sally like that, and Tom like this, So everybody has their preferences for what they're doing and how they want to use it. Theoretically speaking, it seems a matter of indifference which is preferred. And he has a little asterisk down there, and you see, for some remarks tending to qualify this statement, see Part 2, Chapter 2, Section 1, a footnote for formulas for collodion. So he is making a caveat there. So he says it doesn't matter which one you use, but with these caveats. That's basically what he's saying, or with these exceptions. In each case, silver iodide is alike produced with a portion of neutral salt, nitrate of potash, or ammonium nitrate, and there is no reason to suppose that this neutral salt in any way affects the result. The author found by experiment that if the iodides were chemically pure and the collodion new and colorless, no difference could be detected either in sensitivity or perfection of halftones. Meaning, again, he's reiterating that statement. If you do this right and your stuff's in line, you're going to produce good images. Not a whole bunch of difference. So let's look at these salts. Potassium iodide, Ki. This salt is more sparingly soluble than others, meaning that it doesn't dissolve readily in the solvents, only water, right? That's why it gets cloudy and you have that sediment at the bottom of your bottle, all that kind of stuff. The others are indeed the quantity considered by many to be requisite, cannot be made to dissolve in ether and alcohol perfectly free from water. So what he's talking about here is anhydrous, or without water in your solvents. Pure alcohol and pure ether, you're not going to dissolve potassium iodide in those. Even you need water. You need to have it dissolved in water. And even then it suspends and falls out, precipitates out. However, as potassium iodide is easily obtained pure, that was the caveat back in the day, and is a comparatively stable substance, more stable than ammonia, we're going to talk about that, it forms a good basis for iodizing. So he likes potassium iodide. Just the caveats, it won't dissolve in the solvents very well, but it's pure and it's fairly stable. And we don't have to worry about the purity today, but back then they did. Ammonium iodide. This is a NH4I is the structure of that. This dissolves in the ethereal mix more readily than potassium salt. It dissolves completely. You know that if you've ever made any of my recipes, or I have Ki recipes as well too that I use, but for this NH4I, it dissolves in the ether and alcohol, but it has the disadvantage of being exceedingly apt to decompose by keeping, meaning that it turns red quickly or faster than the others. But if you keep it in a cool, dark place and corked up and full, I get months out of mine, literally months. It becomes brown. I don't know why they always say brown. Mine turns red. I've never really seen brown, but I guess, whatever. It becomes brown from liberation or red, free iodine, and is then unfit for use. Now, you shouldn't have an asterisk there too, meaning that unfit for use, yes, if you're talking about optimal conditions, you're not going to be making portraits in a studio with it necessarily. It's going to be very high contrast. I found it's really good for negatives most of the time though. So cadmium iodide, listen to this. This is a beautifully crystalline and very stable salt. So right off the bat, he's elevating this right up to the top of the list here. Easily obtained in a state of purity, again, and very soluble in alcohol and ether. So there you go. You've got the best of both worlds. It's stable, it's pure, it doesn't decompose quickly, it's soluble in the solvents. Cadmium iodide possesses some peculiarities as an iodizer, which distinguish it from the alkaline iodides. Here we go. We're going to start talking about this a little bit. They will be allowed to be more fully in the latter part of the section. Will be alluded to more fully in the latter part of this section. And then he goes on double iodized potassium and silver. This is, well, we'll read it. The general nature of this compound salt has been sketched at page 21. It is, however, at the present time, but rarely employed in iodizing clothing. Absolutely, for good reason. You can read that on page 21 if you download the book. So let's talk about the B section. The chemical changes experienced by iodized collodion on keeping. Meaning, let's talk about what happens when you keep it, or keep it on your shelf or in your cooler. Iodized collodion, when first prepared, is perfectly colorless if the materials employed were pure, which ours is today, of course. It does not, however, long remain so, but begins to change by degrees of a lemon yellow color, afterwards to an orange yellow, and finally to a dark red. These effects are due to the liberation of free iodine. We know that, right? We've talked about that quite a bit, which usually speaking can be detected in the solution by its appropriate test. And he talks about here the Starch Test down here. We can look at that, or you can read that. This liberation of iodine is produced by the ether rather than by the other constituents of the collodion. Remember this. It's produced by the ether. Not that this fluid produces any such results which are perfectly pure, but that it is liable to have its properties changed by gradual decomposition. It is common amongst photographers to say that the effect is due to the slight acidity of the ether. The simple fact of the acidity, however, does not altogether explain the phenomenon. The tendency of ordinary acid placed in contact with the iodide of an alkali is to set free not iodine, but hydriodic acid. That is to say, iodine in combination with hydrogen, Hi. And although the hydriodic acid is an unstable substance and soon becomes decomposed, yet it does not do so sufficiently quickly to strike an immediate color. So he's saying, which is really weird here, because I've mentioned this before on the show. Back in the day, we had, I think there's a couple of times over the couple of decades I've been doing this, we purchased ether that wasn't clean of acid, right? You know how ether's made, sulfuric acid. It wasn't cleaned of acid. So it had a tiny, tiny bit of acid in the ether. And you'd mix up a batch of collodion and it'd go magenta pink immediately, just right off the bat. And I never checked the pH of the ether, but it is slightly acidic, like a pH 4 or so, maybe 5, 4.5, 5. So maybe this was like a 3.5 or 4, I don't know. So what he's saying there, other photographers, it's common amongst other photographers to say the effect is due to the slightly acidity of the ether. I understand what they're saying there. So, and I've experienced that, but he's blaming it on this hydriodic acid in combination. Although the hydriodic acid is unstable substance and soon becomes decomposed, he doesn't say it does so sufficiently quickly to strike an immediate color. So he's kind of poo-pooing that idea, but you know, there it is. There are indeed certain acids which eliminate iodine exceedingly rapidly from the potassium iodide. For example, those which contain oxygen loosely combined, and for instance, the nitric acid, or better still, the same saturated with the red vapors of nitrogen peroxide. Nitrogen peroxide and hydriodic acid instantly react upon other with formation of water and free iodine. Thus, and there's your equation there. Thus, some have thought that the coloration of collodion, iodized collodion, is in all cases to be explained in this way, that a portion of pyroxaline suffers decomposition and that the nitrogen peroxide is set free. A new theory, right? A new idea of why this is happening, which is interesting. And it's good to explore these things. This may be the case possibly to a certain extent, but it does not altogether explain the facts, because the same, and there's the little asterisk on checking your stuff there, Starch Test. The same coloration takes place, although more slowly, in a solution from which pyroxaline is admitted. So he makes his claim and then he goes back. And so really he's kind of unsure on this. No investigations appear to have been made upon the precise nature of the particular compound existing in ether, but it is produced in either of the following ways. By exposing ether to the joint action of air and light, which it oxidizes, right? We talked about peroxides, right? Those peroxides forming, this is nitrogen peroxide. After a time, the fluid assumes a distinct acid reaction, which is probably due to acidic acid. And that's what happens in the silver bath as well, right? By long keeping, a portion of ether, which was originally free from it, acquired the property of liberating iodine after having been kept for 6 months. In this case, the action of air and light have been excluded, but the change, although delayed, was not thereby altogether prevented. So he said this is going to happen with the ether one way or the other kind of thing. And then C, by introducing a red hot wire into the bottle containing the vapor of ether mixed with air. There you go, heat and light, right? I don't recommend doing this, by the way. No red hot wires introduced to ether. He's just saying this is another way. In case of considerable development of the principle takes place, the rapid oxidation is probably hastened by the elevation of temperature. So he's saying that it's so hot that it actually hastens it. It kind of stops it. Mode in which ether may be freed from this particular principle. Mere washing with water does not suffice, but redistillation from a caustic alkali appears to answer the purpose effectually. The coloration of, and then he goes on to say, the coloration of iodized collodion as affected by the nature of iodide employed. So here we go. This is more relevant. Some iodides decompose by ether more easily than others. Ammonium iodide, for instance, colors more quickly than potassium iodide, whilst the cadmium iodide scarcely colors at all. This fact was pointed out by Mr. Hadow, who does not, however, attempt to explain it. Further changes in the composition of the collodion caused by the gradual reaction of the iodine upon the ether. This subject requires to be further studied. Collodion only slightly tinted with iodine regains its original properties if the iodine be removed. So he's really going on there, but it's doubtful how far this case will, when the coloration has been extensive and time allowed for further changes to ensue. So he's going on about, we know this much about it. We haven't looked at it in depth, but this is what we know. Ludwig, or I don't know how, Ludwig has examined the effects of bromine upon the ether and finds the fluid is decomposed gradually with the production of, there again, hydrobromic acid. Oh, this is hydrobromic, sorry. This is hydrobromic acid, hydrobromic ether, and bromol and formic acid. Possibly in the case of iodine, the change may be analogous, but less strongly marked, the chemical affinities of that element being weaker than those of bromine. So he says this doesn't really occur with bromines or bromides. Simple processes for removing the liberated iodine. I read this to you last week. The amount of free iodine required to produce a lemon yellow color is so excessively small that it can scarcely be said to produce an appreciable effect into the photographic point of view. When the tint, however, reaches to an orange or red color, it may be desirable to remove it. This may be done by adding a small portion of caustic alloy, such as potash or ammonia, but better still by the simple and ingenious plan proposed by Mr. Crookes, placing a piece of silver foil in the bottle containing the collodion and allowing it to remain as long as required. Silver iodide is first formed, which afterwards dissolves in the alkaline iodide. A strip of metallic zinc likewise produces the same effect, decolorizing the collodion. And we read about that last week. So here's the question. Do you know why you choose the iodides you do in your collodion? That's the real question to ask yourself here. Because if you're making negatives, I can tell you the best choices. And if you're making positives, I can tell you the best choices. And I can tell you if you're making positives and you don't make very many plates, I can tell you the best choices. You can kind of figure those things out. And that's what he's stating in the beginning of these pages. He's talking about know what you want to do, what variant you're using, know what you want to produce, and how long you want to keep this stuff around. Jan says, can silver baths stored a long time in the tank make more free iodides reactions change pH? More acid? Yes, it can. You decompose anything you have, Jan. If you have your silver bath, even in a tank, and you have the lid on it, unless it's really sealed up, and most aren't, unless you use one of those Lund tanks that really seal down, you're going to have that oxidation occur. Absolutely. And you're going to break that down. Nitric acid, acetic acid, your pH is going to drop. You're going to have a lower pH. The bath was very little used before, stored away in a dark tank. Yes, more acid. Absolutely. That's absolutely true. That does the trick. Yep. So understanding iodides are really important. The function of them are all the same, right? We're talking about the functions of iodides in collodion, but we're also talking about these peculiar, as he calls them, distinguishable effects between the cadmium iodide, the ammonium iodide, and the potassium iodide, Ki, NH4i, and CDI. Those are basic, and there are other iodides, but those are the main kinds of salt or iodides we use, and they used back in the day. So, and we can come back to iodides if you have any questions, but here, let's go on to the silver bath. So here's section 3. This was section 2. So he's marrying these two, and we've often talked about this kind of balance and this understanding of what you're doing with your collodion, your silver bath, your developer, those kind of harmonious synchronization kind of ideas or synchronizing those compounds. So section 3, the nitrate bath or the silver nitrate bath. The solution of silver nitrate in which the plate coated with the iodized collodion is dipped in order to form the layer of silver iodide is known technically as the nitrate bath. The proper management of it is one part of the knowledge required in a practical photographer, meaning that it's easy to mix up some silver nitrate and some distilled water, but understanding how the silver iodide is formed and then maintaining that silver bath, because it goes through a lot of changes. Every plate you dip in there, it's going to go through some changes. So those are really important to understand. And that's what he's talking about. Hey, stand up for Judas, a bit late, but hey yo to you, Judas. Good to see you. So he goes on to say, at present, we notice the following points connected with the chemistry of the bath. For instance, A, its properties of dissolving a certain portion of the iodide of silver, and B, the changes the changes it undergoes by exposure to the light, and C, acidity of the silver bath, and D, the alkalinity of the silver bath. These are really important. I'm going to do a little bit of a deep dive here for you, because I've got a couple of emails this week about silver baths and about how to do maintenance and what the best way to handle these problems are. And I want to talk about what's happening in the silver bath. So let's talk about this. Let's go to A, and we'll go all the way through them. Give me a little drink of coffee there. Let's go to A, a property possessed by silver nitrate of dissolving silver iodide. Silver nitrate was mentioned in the second chapter in the list of solvents of the silver iodide. The proportion dissolved is in all cases very small. All right. He's saying that what happens on your plate, it's a very tiny amount of silver iodide, but it happens. The proportion dissolved is in all cases very small, but it increases with the strength of the solution. If no attention were paid to this point and the precaution of previously saturating the silver bath or the nitrate bath with the silver iodide neglected, although the film would produce equally well at first, yet it would be liable to be afterwards attacked and dissolved away. And we're going to get to that. He's talking about what he basically said there. If you just mix up a silver bath and you start pouring plates and dropping them in, you're going to be fine at first. But at some point along the way, you're going to have problems. And I get those emails. Hey, I've been using my silver bath for 6 months or even a year sometimes. And all of a sudden, it doesn't work anymore. I think it's a silver bath. What happened? Well, let's see what Hardwich says about it. This solvent power of silver nitrate on silver iodide is well shown by taking the excited collodion film out of the bath and allowing it to dry spontaneously. This is interesting. The layer of nitrate on the surface becomes concentrated by evaporation and eats away the film in parts as to produce a transparent spotted appearance. So we've talked about this. We're putting this plate in with these salts in this silver bath, and we're even with negatives, we're stopping it very prematurely. But this process is even taking place as you go and put it in your bag, make the exposure, all that stuff. It's still going on. It's still going on. And he's saying here, you can actually see that if you let it dry spontaneously, meaning you just let it sit out. You'll see this happen. In the solution of silver iodide by silver nitrate, a double salt is formed. We've talked about this a lot as well too, which corresponds somewhat in the properties of the double iodide of potassium and silver. That is to say, it is decomposed on the addition of water. Consequently, in order to saturate a bath with silver iodide, nothing more is necessary than to dissolve the total weight of the silver nitrate in a small bulk of water and add it to a few grains of silver iodide. Perfect solution takes place. On the subsequent dilution with the full amount of water, the excess is precipitated to form a milky deposit. So you get that idea. We know what happens. You salt that plate, you put it in the bath. This double decomposition takes place to change those salts to silver iodide and silver bromide, AgI, AgBr. And he's saying if this is out of balance, you're going to have a problem with your bath. And if your bath is oversaturated with iodides, you're going to see this. And we'll talk about this milky solution here in just a second, or in just a minute. So B, chemical changes produced by exposure to light. Pure solution of silver nitrate is not affected by the action of light. People say, well, why do you have your silver in a clear bottle? Because I keep my silver clean. It keeps me honest. And if your silver nitrate is clean, it doesn't matter how much light hits that. It matters if you have organic material or anything that can react to the silver, then you're going to have this foggy, milky, black stuff come out of it. That's if your bath is dirty, right? So silver nitrate is not affected by the action of light. You have to have a salt. You have to have some organic material in combination with it to have it react. The nitrate bath, however, although pure at first, does not long continue to be so. Very true. Really, you could argue one plate and you're starting to change this bath. Each time a coated plate is dipped, organic matter in the shape of alcohol and ether is introduced, for sure. This organic matter, in conjunction with light, soon reacts upon the silver nitrate, and causes a brown deposit, which settles in small quantities at the bottom. And we even have a kind of a unique phenomenon today, which I get quite a bit of now. I get not recently, but I have in the past. People using aluminum plates, they'll cut the plate and that edge is a little bit exposed. They put a whole bunch of them in their bath, and then they pour their bath out and they filter it through a cotton filter, whatever, or a coffee filter, cotton balls, and they'll get these little black balls. That's a reaction of aluminum. Aluminum is reactive to silver nitrate to some degree, not as much as other metals, of course, but it is reactive. So you're starting to change. You've got solvents going in there. You've got nitrates coming off in this double decomposition, and you have in our case aluminum. If a lot of people use aluminum, you're going to have a slight reaction there as well too. Let's see. Jan says, so with fresh collodion will work with more acid in the silver bath then. Actually, you want the other way. You'd want to use a more decomposed collodion with a used silver bath, meaning that you may have a tendency to fog. The lower the acid, and I understand what you're trying to say, the more acidic, the more acid you have, the less reaction you're going to have, right? The more alkaline you have, the more reaction you're going to have, but you're also going to have the tendency to fog. This is a problem. So, I mean, a fresh collodion will work. Yeah, well, yeah, and he's asking, so I'll read his question. So with fresh collodion, it will work better with acidic silver bath. Yes, that's true. You want to restrain that activity. Yes, that's true. But I was thinking if your silver bath is older, Jan, you might want to use a more decomposed collodion. But yes, you're right. That is absolutely true. So I just kind of misread that. But yes, very true.
Quinn.
Yes.
Quinn. It was only used for 3-4 plates before I store it.
Perfect.
So
yes,
it's look clean and everything.
Yep, perfect. You're right on.
Yes, and
a new collodion with a more acidic bath. Perfect. That's what you want, because a new collodion is more active. We know this, right? That decomposition hasn't taken place. So you want your acid in your bath to be higher to restrain that, especially if you're making positives. And I assume that's what you're doing. Yes. So we go more alkaline with negatives. We want more of an action, but we don't want to cross that line where we start fogging. And that's where the alkaline and acidity takes place. But you're absolutely correct, Jan. Yeah.
Okay.
So
thank you.
Absolutely. Thanks for the question. It's good. It's a good question. So it does not long continue to be clean and pure on the silver bath. A couple of plates, you're going to start having this, at least the solvents and the nitrates happen. Each time a coated plate is dipped, organic material in the shape of alcohol and ether is introduced. This organic matter, in conjunction with light, soon reacts on the silver nitrate and causes a brown deposit to small quantities at the bottom. The deposit is metallic silver, and it is produced by a regular process of reduction, oxygen being separated and combining with the reducing agent in the usual manner. If a careful analysis of the bath be made after a certain time, probably silver acetate. Acetate and nitrate of silver will be detected. So he's nitrite, sorry. So he's talking about silver acetate and silver nitrate. It would be detective if you actually did an analysis on your bath. The former is produced by the oxidation of alcohol and ether, right? The acetate and alcohol or ether into acetic acid. By the oxidation of alcohol or ether into acetic acid, and the latter is the first stage of the reduction of the silver nitrate. So the nitrite's the first step in that. The others, alcohol and ether, produce the acetic acid, is what he's saying. And he's got a little asterisk here, but the properties of the solution as far hereafter seen are materially affected by these changes in the composition, and hence it is necessary to bear in mind that the silver nitrate bath must be kept carefully excluded from the light. I just told you I keep mine out, but if you read in my book, I do this what's called regular maintenance, and that's by evaporation, filtering it, putting back in the bottle. I don't keep it out in the sun, let's say, but I do keep it in clear bottles. And I kind of want to see what's going on. I'm pretty tidy with my I'm very tidy with my silver bath. I am. So if you're not tidy with your silver bath, you might want to consider keeping it in a darker situation. So, and he's saying, look, let's put this in context. These guys work their baths every single day, making God knows how many images, right? Hundreds of plates a week, probably, for a lot of them, right? So these are baths. We're not talking today in the 21st century, 20th and 21st century, about making a few plates a month or even a couple of plates a week or whatever. These guys work their baths. So that's a different situation. That's in context. So, and then he goes on to say, probably there are other effects besides those above mentioned produced by the continued action of light on the bath. He's saying there's probably other things happening with the light. We just, sometime since a bath was placed in the hands of the author for analysis, which yielded distillation of volatile organic substance possessing curious properties. So he goes on to say he got this bath and he's checking it out to see what's in it. And he's saying there's a volatile organic substance of curious properties in it. It had a peculiar smell, distinct from that of either constituents of collodion, meaning alcohol and ether. And when added to a pure solution of silver nitrate, caused a universal decomposition of the film of silver iodide under the influence of a developing agent. So he's saying there, and what he's really talking about here, we talked about this with Estabrick. He's talking about these other organic materials, these byproducts, right? We're talking about nitrates. You've seen the little illustration. I'll put it up again here. You've seen this illustration many times, right? The CdNO3 and the NH4NO3, those are byproducts. And there are some other ones too, by the way. And here's the other illustration of the highly iodized 30 and 40 grain bath and slightly iodized 8.8% and 6.8%. So interesting stuff. I love this. I love to go through this and read this material. So let's go on to C, the acidity of the bath. And then we're going to talk about the alkalinity of the bath. The photographic properties possessed by a silver bath. There's the little asterisk from before, but you can read that later. That's a different story. By nitrate bath, very much accordingly as a solution is in an acid or neutral state. So let me just clarify here. What are we talking when we talk about an acid or neutral state? Well, in pH or parts of hydrogen or power of hydrogen, we're talking about a neutral reading of pH 7. That's a neutral state. pH 7 is neutral. Slightly acidic would be a 5 or 4, somewhere in there, slightly acidic. Very acidic would be a 2, maybe even a 1, but definitely a 2. And alkaline or an alkaline solution would be, you're starting around 9, 8 or 9. You start getting into alkalinity there. If you go right out to 14, 12 to 14, lime and baking soda and ammonia, and you go down to 1 sulfuric acid. That's kind of the scale. So when we talk about neutral, we're talking about pH 7, slightly acidic, 4, 5, 4.5, 5, somewhere in there. Just keep that in mind when you read this, and you'll read about litmus paper in here, right? Red and blue litmus paper. Blue is neutral, red is acidic. So keep that in mind. I know they didn't have pH scales back in the day. So solution is in an acid or neutral state. At present, we confine ourselves to an explanation of the manner in which acidity of the bath is caused, leaving its photographic peculiarities under another occasion. Pure silver nitrate is neutral to test paper. Okay. My silver nitrate, I don't know about your silver nitrate, but my silver nitrate, if I take 85 grams or 88 grams or 69 grams, whatever bath I'm making, and I pour a liter of distilled water and I mix that up and I check it, it's around pH 4. It's slightly acidic right out of the gate. So I don't know if they went further back in the day, but he's saying it's neutral to test paper, meaning that it's a blue color, pH 7. So there's a little bit of a discrepancy there. But the nitrates sold in the shops have mostly an acid reaction. Maybe that's where we're at. This arises from the fact that the crystals have been imperfectly drained from the acid mother liquor. I love this. Mother liquor. I love that. That's just so fun to say. In which they were formed. Hence, in making a new bath, it is necessary not only to saturate it with silver iodide, but to neutralize it free from the acid it contains. So let's put this in context. He's talking about making negatives here. When you're making negatives, you don't want an acidic bath. You want a more neutral bath making negatives. You want a stronger, you want to take up more silver, right? We've talked about pH before, and more silver is applied. The action is better with a more neutral bath. More acidic bath, you don't take up as much silver, and it's great for positives. You want a very thin negative for positives reflected with something black behind it. You want it thin, and you want it clean, and that will give you that. And you don't need it. You don't need it that the exposures are going to be very short with that thin negative. So hence making the silver bath, you need to free it from acid. Supposing the silver or the nitrate bath, however, to be perfectly neutral when recently prepared, it is very shortly becomes acid by continual use. And we know why this is, right? It's releasing the nitric acid in it. We've got other chemical responses happening in that bath with every plate we put in it. The ether, the alcohol, acidic acid. We understand this now. We understand how this process works to a large degree that way. The acidity in this case is caused by the employment of collodion containing free iodine, meaning that you're using an orange, yellow, orange, even a slightly red collodion that's iodine releasing into the bath, creating the acidic content, in which a portion of nitric acid is liberated each time the plate is immersed in the bath. Thus, there you go. Silver nitrate plus iodine, silver iodide plus nitric acid plus oxygen, or Ag. You see the symbol there. You understand what's happening in your bath. Observe not only that the nitric acid, but also an atom of oxygen is set free by the iodine. How far this influences the result is not very easy to say, but probably being in the nascent state, it immediately combines with organic material and is removed out of the way. Practically speaking, it's useful to bear in mind that the free iodine in the collodion is equivalent to the free nitric acid in the bath, and that the effect of constant use will be to render the solution more and more contaminated with nitric acid unless care is taken to remove it. And that's really where we're at. So you start to understand this process of using your bath, putting that collodion, salted collodion in your bath every time, and creating this acidic nature of your silver bath. People always ask me, okay, well, if does your bath become more acidic or more alkaline? It becomes more acidic. You're never going to have to deal with the other way necessarily. But let's read this: the alkalinity of the bath in the D section. By alkalinity of the bath is meant a condition in which the blue tint of the test paper is restored to reddened litmus paper. Such a fact indicates that a metallic oxide of some form is present in solution, which, by combining with the acid in reddened paper, neutralizes it and removes the red color. If a small portion of caustic potash or soda, and we like to use baking soda or ammonia, right, added to a strong solution of silver nitrate, it speedily produces a brown precipitate, which is the silver oxide. The solution, however, from which the precipitate has separated is not left in the neutral state after such addition, but possesses an alkaline reaction, meaning that now we're going up the pH scale, not down the pH scale. This effect is caused by a minute quantity of the silver oxide, which is displaced by the stronger oxide, potash, dissolving in the liquid, or ammonia or baking soda, any of them. For all practical purposes, silver oxide may be said to be insoluble in water, but after participation, a trace always remains, and probably the quantity dissolved becomes larger if the water holds silver nitrate in solution. So he's saying you could grow now, you can go the other way up the scale by using these compounds. Silver oxide and silver carbonate are also abundantly soluble in water containing the ammonium nitrate. And as this salt is continually accumulating in the bath, when compounds of ammonia are used for iodizing, it is well to bear such a fact in mind. So that's what I use, right? I use mostly the ammonium iodide in my bath because I like to make negatives. You make negatives with ammonium or potassium iodide as well too. But this is what he's talking about, the nitrate of ammonia. You saw the byproduct there, right? That screen there it is, ammonium nitrate, NH4NO3 right there. That's what he's talking about. The production of ammonium nitrate by use of collodion containing ammonium iodide is thus shown. He gives you the breakdown there. Now, alkalinity of the bath is most pernicious condition. I love that. Pernicious canids. I don't know, Willy Wonka. Sorry, one of my shows, right? I like that show. Pernicious condition. It's a bad condition, photographically considered, and therefore it will be well to lay down the following rules in order to avoid it. First, so here we go. First, never employ a collodion containing free ammonia or ammonium carbonate. Okay, we won't do that. If such is done, oxide and carbonate, silver oxide and silver carbonate are formed at every dip of the plate. So you're saying, be careful what you put in that collodion, right? And after a time, distinct alkaline reaction is produced. So now you're going up the scale. Rather than having the iodine bring it down, now you're going up if you're adding certain things to your collodion. And even the ammonium nitrate is kind of the ammonium, the NH4I can cause this, as he described before there. If such is done, it's produced at every dip of the plate. Second, in attempting to neutralize a bath which contains a free nitric acid after the addition of carbonate of soda, baking soda, which perhaps is as good an agent for the purpose as any other to test for alkalinity, and if any is discovered, to add a single drop of acetic acid and then test again. The fact of a drop of acetic acid, glacial acetic acid, often sufficing to neutralize the whole of the silver carbonate dissolved in a bath, perhaps 8 ounces or more, shows how sparingly soluble this salt is. Nevertheless, even the minute quantity is enough to produce injurious effects. He's saying glacial acetic acid, as weak as it even is, it can neutralize this alkaline producing compound. That's basically what he's saying there. And he says, look, we're going to get into this. Alkalinity is far more injurious than having acidic. Acid will slow you down, may discolor you a little bit, but alkalinity will fog constantly. You'll never get rid of the fog. Let's talk about now getting rid of these compounds, right? Getting rid of all these things we just talked about. This is out of his same book on page 272. One of the most potent destroyers of negative or positive bath for collodionized plates formation therein is nitroiodide or nitrobromide of silver. It is necessary to explain this phenomenon shortly, as the facts have now been fully ascertained and the causes traced to their sources. When an iodized, bromoiodized, or bromized collodion film is being sensitized in the silver bath, the first effect of the silver is to convert the soluble iodide into corresponding silver salts, or salts of silver, AgI and AgBr, right? If you're using bromides and iodides. When that is complete, the excess of silver nitrate begins to dissolve out or destroy its own offspring. This is interesting. I love how they use this verbiage. After a time, when the nitrate becomes saturated, And then the new compound crystallizes out in fine needles, crystals in the silver nitrate bath, or more generally in the collodionized film. Alcohol and ether in the bath loves that stuff and favors it. And the decomposition of these crystals, which are insensitive to light and constitute one or more fertile cases of pinholes or transparent spots and negatives. What he's saying there is that once you get this event going on where you have so many iodides in your bath, they're going to fall out and go right into the collodion, into the film. And alcohol and ether loves them, and they're insensitive to light. And alcohol and ether loves them, and they're going to dissolve out and create pinholes. They're going to make transparent spots all over your plate, and they're going to be very consistent when this happens. And Jeffrey gave a good example of something that confuses people with this, and we're going to talk about that in a minute. Simply iodized collodion is less liable to this influence than bromo-iodized. Did you know that? If you're making negatives and you only use an iodizer in your collodion and you're making negatives, not a bromide too, you're going to have less of an issue with pinholes. Interesting, right? I thought that was interesting. If the nitrate bath is otherwise working well, the best remedy, now this is really important here, guys. Pay close attention to this, because somebody just pointed out a post on one of the forums that were completely inaccurate. So if a bath is otherwise working well, the best remedy is to add to it 1/3 of its bulk of distilled water, which will throw down a large proportion of the iodide and bromide, which it is taking up. Do you remember we talked about this? Sutton, Estabrook, we talked about how you have pinholes, an excess of iodide, silver iodide in your bath. And we talked about you don't add water to that, you add that to water. Right? 1/3. So for instance, if you had a liter of silver bath that you needed to get rid of those iodides out of, you don't pour that into a jar and then add water to it. You pour the water in, the distilled water into the jar and add the silver bath to that. This is the only way to precipitate or pull out those iodides. This is really important. And I know the devil's in the details here. You've got to read these texts really closely to understand what they're talking about here. And this is what he says. Let me read that again. The best remedy is to add to it, the bath, 1/3 of distilled water, which will throw down a large portion of the bromide, iodide, and bromide, which is taken up. So and Sutton says this, Estabrook says this. This is the practice. If you take nothing away from today, when you do maintenance on your silver bath, don't add water to your bath, add the bath to your water, and you'll pull those out. You're trying to get rid of the iodides. You're trying to get rid of that material out of there, and that's how you do it. 90% plus of it's gone if you do it this way. Filter and then dissolve in the silver nitrate in proportion of the quantity of water needed, and then acidify if necessary. So if you're doing a 35 or 40 grain bath, that's what you've taken 300 mils. You can add that proportion of silver back in, and then acidify if necessary. Bring that pH down. If you started neutral, we'll talk about that. You want to bring it back down a couple of points. With reference to an excess of organic matter in the silver nitrate bath, the best way to test for failure is the direction it takes a proportion of the solution and make it slightly alkaline with ammonia. So what is he talking about here? He's talking about those byproducts from the double decomposition. He's talking about the byproducts, cadmium nitrate and ammonium nitrate or potassium nitrate, whatever you're using it. That's what he's talking about here. So he's saying you can take a small portion of that and add some ammonia to it and test it to see if you have a problem with that. If you have pinholes, remember, go back. If the nitrate bath is otherwise working well, that's what he's talking about, getting rid of the iodides. Now he's talking about if you also have a double decomposition byproduct problem or organic material problem, this is how you take care of it. Make it slightly alkaline with ammonia. If by exposure to strong light, the liquid does not become turbid after 2 hours and the organic matter is not present in excess. So there you go. That's how you can test for these other byproducts. And we know how to get rid of solvents, right? Heat and light, put it in a big jar, put it out in the sun. You're going to evaporate your solvents off, your alcohol and ether. ether is going to go quick. Alcohol may take a little bit longer. If by this reducing power of light on solutions of silver nitrate containing organic matter is taken advantage of to purify them. Proceed thus. Pour the impure bath into the transparent wide mouth jar. I use a big, you've seen my big glass cookie jar. Now I've got another kind of aquarium big jar. I can do like 8 or 10 liters at a time now. Transparent, meaning, glass, wide mouth bottle. And add ammonia drop by drop till red and litmus paper indicates by becoming blue, meaning you're neutralizing the bath, right? Ammonia, you drop, and you're neutralizing, you're raising that pH by becoming blue. The solution is slightly alkaline, meaning probably pH 8, pH 9, somewhere in there. It is better not to stopper the cork bottle, as it is important to allow any ether or alcohol which the solution contains to escape. Dust may be kept out by placing loosely covered mouth over the fold, meaning put a piece of muslin or something over it to let the alcohol and ether. Yeah, I don't even care. I've got bugs and crap in mine. It doesn't matter. I'm going to filter it out anyway, right? This does not materially interfere with the escape of vapor. That's all. Just make sure you don't put anything over it that will prevent the solvents from evaporating. The vessel is now placed in the sunlight or strong diffused light in a place where rain does not find access to the interior. After a few days exposure, most of the organic matter will be precipitated and reduced in combination with a part of silver to a black powder. In other words, put it in. You take all your nitrates out with ammonia. You bring it up to a little past neutral. Cover it up. Let alcohol and ether evaporate. Set it out in the sun for a few days. Here it only takes a day or two, and I've got a big black sludge at the bottom of it, and you're good to go. The time of reduction varies according to the intensity of the light and the amount of organic matter present. Yes, if you have a hard work bath, you may be a couple of days or whatever. He says 5 to 30 days. That may be in England or some parts that don't get much sun. The bath should, or Canada. The bath should now be filtered, but if it is an old one, fully saturated with iodide and bromide of silver, it is better before filtering to add, say, a third of its bulk to distilled water. Again, we're back to that same thing. He's talking about 2 different methods here, removing iodides and removing these byproducts. So he's going back through that again. And he goes on to say, if, however, the weakened silver solution is well agitated and allowed to stand for a day or so, the particulars will amalgamate and fall to the bottom. They'll fall out and fall to the bottom. The solution should now run through a filter, perfectly clear. The rendered bath, again, fit for work. Dissolve it in silver nitrate. Bring the proportions up to whatever you're using. 35 grains here for him to each ounce of distilled water used in diluting. Acidify it with either nitric or acetic acid as previously directed in making a new bath. Such solutions, when corrections have been properly made, work quite well as new ones. This is really important to understand because the silver bath, and it's important to have a couple of silver baths. So if you have one go down or one needs to be maintained, you can let that sit for a few days or a week or a month or whatever you need to do. And you have another working one. I have several. I'm a little paranoid. A bath goes down. I don't want to be shorthanded. So this takes time. It's a big deal, as you can see, making out what he's talking about. So let's just recap this maintaining silver just in more 21st century language. What does maintenance do? It removes the solvents, evaporation through alcohol and ether through evaporation. And it removes organic material, iodides in excess and nitrates, ammonium and cadmium, or potassium, whatever you're using. How do you remove the solvents in alcohol and ether? Aeration and or heat, sunning in an open glass jar, just like he says. How do you remove iodides and nitrates? This is mainly for iodides here. Add the silver bath to a third of the volume of DH2O, not the other way around. We emphasize this again. This will concentrate, isolate them. You'll get that milky stuff going on. For example, 1 liter bath would require about 300 mils of DH2O. So you want to add the silver bath to 300 mils if you're working with 1 liter of DH2O. Neutralize the bath with baking soda or ammonia. Use a small amount. Get to pH 7-ish. Sun or heat the bath until the organic material is isolated, and you can decant and filter the clean silver. I don't like if I have a hard work bath, I like to decant. I don't like all that. I don't like to try to filter out all that sludge. I have before, but sometimes it's a lot easier just to decant right down to it and then leave that and dispose of it, neutralize it, and dispose of it. Add AgNO3 to bring the working solution 6.5 to 8.8, whatever solution you're using. Add acetic acid, or glacial acetic acid, or nitric acid to correct 4 or 5 pH, whatever you're working in. That's kind of the overview of that. And then here's one more. This is out of a different book. I didn't mention this, but this is Practical Photography on Glass and Paper by Charles Long. We're going to go into this book next week, but failures attributable to the state of the silver nitrate bath. Somebody wrote me this week and asked me about this, so I sent this off to him. Of all the misfortunes that can possibly befall the collodion operator, perhaps there is none which gives so much trouble as the fogging of the pictures. Probably this arises from imperfect knowledge of the causes that bring the state about. You're going to see a new cause or something that people don't talk about a lot here. I've never seen anybody talk about in this description here. But in all cases may be referred to the state of the bath. For negatives, the bath ought to be in slightly acid condition and exactly saturated with silver iodide. So there's a little different take on that, right? When these conditions are obtained, the bath will yield clean and perfect pictures on development. But when he's talking about a pH 5 or 6 there. But when any cause of the bath should have become alkaline, that is to say, when tested with litmus paper, fails to give an acid or neutral indication, then the plates will all become fogged under the action of the developing solution. This fogging may be explained by clouding over the parts of the picture that ought to be transparent, and when positives are printed from the fog negatives, great want of contrast is always observable in them. He goes on to say, the immediate cause of this veil or cloud, we call it fog. Veiling is more developer for us, right? This veil or cloud over the picture is the decomposition of the silver iodide by the developing solution, independently of the action of light. And tracing the matter to its source, we find that the real cause of fogging is that the silver iodide precipitated from an alkaline bath is decomposed by the developer. Then he goes on to say the remedy is simple. In the extreme, we have only to add drop by drop the best and purest glacial acetic acid till the litmus paper indicates a slightly acid reaction, as described on page 16. Slightly acidic is pH 5, pH, you could go to 4 if you're on positive. For here, negatives, I'd say 5 or 6. But independent, now look at page 35 here. But independently of the above causes of fogging, there's another which, until its remedy is known, is apt to give great annoyance. It is the fogging that becomes on mostly in warm, very warm weather, more especially if the bath has been allowed to evaporate. It is fogging by supersaturation of the bath with silver iodide. Under these circumstances, the bath may be perfectly clear and indicate an acid reaction, and yet the pictures are fogged, and this is to be attributed to an excess of silver iodide in the bath. The remedy in this case is to add the bath to about a 1/6 part of its volume of distilled water. In this case, the milkiness of the solution precipitate the iodide, pass the bath on in the state of the filter, clear the solution. He goes on to say 30 grains to the ounce. If we now take a picture on the plate prepared in this bath, we shall find it quite free from fog or cloudiness. So he's talking there about a different, not adding acid or bringing, not adding or bringing, adding the glacial acetic acid. He's talking about getting rid of the iodides causing the fogging, not the pinholes, but the fogging. Very interesting, right? So heavy maintenance in my book, I describe heavy maintenance that way. It gets rid of all of these problems, pinholes, fogging. It cleans your bath up. That's the point of all of it. So I thought that was very interesting. And next week we're going to talk about his book here, Practical Photography on Glass and Paper, a manual by Charles Long. This is 1856. Again, I know I say old books aren't sometimes that great, but you can pick out these few and they're pretty good. So if you have any questions, log in. I haven't looked over here, but comment. Okay, good. Okay. So Jeffrey sent this over to me. This is really good. I appreciate this. I created the contrast a little higher in this so you could see it a little better. But here's the thing. We get these questions all the time. Somebody will post something up online and, oh, those are pinholes. And no, they're not pinholes. These are not. This is not what we were just talking about. This is a fix issue. This is an exhausted fix issue is basically what it is. And how do you know they're not pinholes? Because they're not consistent and they're not small. You'd have to really get it. These are all various sizes. They're splotchy. They're all over the place. So what is this? This is a fix issue. This means you fixed too many plates in the bath that you're using. And what you have happen is you have the silver. Basically, you're producing this like in cyanide, silver cyanide or hyposilver, that kind of stuff. That combination, when you fill your bath up with you're clearing the silver, the unexposed silver off your plate and filling your bath up. Now that gets so full, it's kind of like pinholes. It's going to come back down on your plate. Sometimes this stuff shows right away, and sometimes it takes weeks. It just depends on how saturated your bath is. We've emphasized here many times, in a perfect world, you'd only want to run 1 or 2, 3 plates in your fix. Use as little as possible and then discard it, because that saturates quite quickly. And this is definitely, I appreciate you sending this in, Jeffrey, because this is a great example for people to see. This is not pinholes. This is not your silver bath. This is your fix, your exhausted fix bath, and it's really good. Really good example. Tim, you can download that on Google Books. Just go over to Google Books and type in Hardwich's name, the title of the book, and you'll find it and you can download it. There's a couple of versions. You can get any of them. They're all good. The one I'm using is you saw on there, the 1855. Stand Up for Judas says, let a silver bath sitting in one of my techs unattended for several months and got crazy artifact. Yeah, exactly. Seems that just leaving it sit can cause issues. They look very interesting. Yes, it's a very good point. I'll reiterate a story that I've told on here a few times. I had a guy back in Massachusetts. We were talking, this was long, 15 years ago. This is a long, long time ago, maybe longer. We were talking one time, he was showing his plates. He had all kinds of crazy artifacts going on. He says, what's happening here? I'm like, wow, I don't know. Let's break your situation down. What are you doing? Blah, blah, blah. So I start, silver bath. Tell me about your silver bath. He says, well, it's out there in the barn. It's sitting in the tank. And I said, do you filter it every day? You put it back in the bottle? What? Do you take it out of the container and you filter it every? No, it's been there 6 months. I've not touched it. It's like, oh my God. So your silver bath is like a sponge. Anything around it, it's going to absorb. You smoke a cigarette around a silver bath and try to make a plate. It's amazing. It's like a sponge. So anytime you leave it out, and I'm not talking about a loose fitting cover on a box, that's not sealed up. Anytime you leave it out like that, you're going to have 2 things happen. You're going to absorb anything in the ambient air, and you're going to evaporate the water. So your bath strength is going to go crazy high, right? Unless you are adding water back into it. And you're going to accumulate all that junk we just talked about, right? So you're going to have these combinations of stuff. And yes, you're right, Stand Up for Judas. You're going to have crazy artifacts on that stuff. It's insane. I've seen it. I've witnessed it. I've never done it because I'm a little too anal for that. But Google Books, I would imagine, seems to be an awesome read. Yes, Google Books is our go-to. This show relies on Google Books. That's all the 19th century manual. Behind me, I have, years ago, I printed out, the silver sunbeam. I printed out everything. I've got everything printed out just in case, Google Books goes down. You don't want to rely too heavily on that. But yes, Google Books is our friend for sure that way. Jan is just starting up again after a few months. Can be for me starting again. Yes, it will be. It's always fun to start over again. But great example on the technical Q&A there. Thank you for that, Jeffrey. That's great for everyone to see that. Really important. I'm glad you saved that plate. Yeah, now he only puts 3 or 4 plates through. That's perfect. Perfect. So recommended reading this week. This is an audio book. I really like Deanne Arbus. I like her a lot. She heavy influence on me in photography, her style, her ideas. She committed suicide in 1972. I don't have a theme here going about women photographers committing suicide. I know we talked about Woodman last week, but this is just, life as we know it. Wonderful photographer, very insightful, very interesting life, very interesting ideas. I love a lot of her conceptual stuff, her ideas and thoughts about why she made photographs of what she made, portraits of, and other things. A great book. You can download the audio portion, grab the audio book of it. Arthur Lubbow. And I wanted to stay in the same vein here. This is only a 3.5 minute clip. Let's watch this. This is Deanne Arbus in the beginning from the Showcase Exhibition series.
She's one of the most well-known American photographers. She emerged in the 1950s, and this exhibition looks at her earliest work, the genesis of her career. And she was essentially a portraitist, and she looked very broadly at the world. She made pictures of people who were right in the middle of the society, and people who lived their more eccentric lifestyle.
This is Deanne Arbus in the beginning. From 1956 to 62, she photographed children, couples, and people living on the margins of New York City.
Her work is arresting
and difficult.
And unlike other photographers of the era, the people in her photographs look directly at you.
People trusted her. They shared their secrets with her. In a certain sense, they chose her as much as she chose them. And she created a body of work that was very distinct from that of her peers. Her peers were trying to hide the camera, trying to sneak a picture, trying to be a voyeur but not be seen. And she wanted a direct connection with them. And she allowed them to use her to present who they thought they were to the world. And that's what the exhibition focuses on.
Identical twins really encapsulate Arbus's
preoccupation with identity. The twins are dressed the same. They have the same haircut. At first glance, there's a real uniformity in everything about them. And yet, look at their faces. This is how they express their individuality. The photograph is also seen as the inspiration behind the twins in Stanley Kubrick's horror flick, The Shining. Arbus started taking photographs in the 1940s after her husband Alan, a respected photographer himself, gifted her a camera. But it wasn't until 1956 that she began pursuing it as a career. And this exhibition includes some of her most outstanding work, including Jack Dracula at a bar. It's a simple shot, and at the same time, it's exceptional.
The idea of working on the street and interacting with people, that direct one-on-one approach, was hugely influential from the day, but it's influenced photographers worldwide, and it's influenced subjects to believe in themselves. So even people who are not image makers, but we're all image making when we perform our own lives. Hugely influential on the film world. A lot of filmmakers look to her as a model of creativity and inspiration.
Arbus took her own life in 1971, following severe bouts of depression. But during her career, she was never afraid to offer a new perspective. She continually challenged perceptions about the traditional relationship between the observer and the observed, and what it means to see, and crucially, be seen. Deanne Arbus in the beginning runs until May the 6th. Miranda Atty, TRT World, London.
So there it is. That's a good.
She's one of the.
That's a good ending to this show. I think exposure and no pun intended, exposure and broadening your visual repertoire, your visual intake is always a good thing. And if you, a lot of folks have heard the a lot of these photographers. Of course, they're quite well known, especially if you have education in photography. You're going to know who these people are, most of them anyway, that I recommend. But if you haven't, they're going to, and even if you have and you haven't looked at them for a while, study up on them, take a read on them, and see how it might influence you. It might inspire you. It might give you some ideas. One of these times, and we should do this sooner than later, we should talk about the influence that Collodion has had on the photography world, on what people are doing with Collodion and what they've done with Collodion. And is it a fair thing to say, oh, it's in Collodion, so it should be honored, or it should be put up higher on a pedestal because it's not digital or it's not film? We should have those discussions, a lot like, in the same vein as is photography even art? Those kinds of questions. Is it mechanical? Is it a great kind of? It's a great kind of discussion to have. And I don't, we won't argue about it, but we'll discuss, your ideas, my ideas, have those conversations about what is it in today's world that draws people to Collodion? Is it fair for Collodionists to get? I get all kinds of every week. Honest to God, every week. Somebody's got an interview, somebody's got a show, somebody's got a newspaper article because they're working in Collodion. Now, the work might be fine, or it might be not so fine, right? It might be undeveloped. It might be, technically poor. It might be, there's all kinds of things, or it might be really good. Those kinds of questions I think we should ask, why we're working in Collodion, what it is that attracts us to the Collodion, to the process, and do we have good, valid reasons for working in it that we can talk about and discuss. So, hey, I appreciate everybody. Yes, I'm sorry. Jan told me my mic wasn't muted, so I apologize for the echo there for a minute. I'll remember to cut that off in the future. Thanks so much for joining me, ladies and gentlemen. It was great to see everyone. Stay healthy and happy. And next week, we'll jump into Charles Long's book. He's got some really good stuff in there. It's always great to reiterate this stuff, because there's always little tidbits you can pick up, always little things you can understand better about the process. And in the end, it's about making our work better, understanding the process better in order to do that. So stay safe, stay healthy, have a great week, and we'll see you next Saturday. Bye-bye. Thanks for joining me.